last problem set is number 5, and we basically are given two simultaneous equations, and we're supposed to show the value of x equals the log of 3 divided by the log of 6. So what you should notice is we have, a problem that definitely is going to involve logs because we have two unknown variables as exponents, and then we have a linear equation, right? So that's not too bad. So we can approach this in a couple of different ways. Since we have logs in our answers, I think that it's pretty clear that we're going to be taking the log of both sides. So here's what I would recommend. Since what I would do is I would take the second equation and solve for y. So y ends up being 1 minus x, right? So y-intercept of 1, slope of negative 1, and I'm going to just go ahead and substitute that into the 2x equals 3 raised to the 1 minus x. Now, if you didn't do this straight away, you could have manipulated the top equation first, the 2 to the x equals 3 to the y, and solved that way, but I think this way is a little faster. Okay, so now, because I have unknown exponents of different bases, I'm going to take the log of both sides, just like we've done time and time again. And then one of the benefits of doing this is then we can kick the exponents out in front per our probably one of the handiest properties of logs, I think. Okay, I shouldn't say that because there's so many handy properties of logs, it's hard to decide which one's the best because there isn't one. Okay, so here's what we need to do. We've got to get the x's together on one side, so I'm going to go ahead and distribute on that left side. So I end up with 1 times the log of 3, which is the log of 3. And then I'm going to say negative x times the log of 3 becomes negative x log of 3. So just like we did on the prior problems we've watched, anytime I have, different log 2, log 3, I can't combine those, but what I can do is get them on one side. So I'm going to add these, and then I can factor out the variable that I need to deal with. Okay, so I'm going to now rewrite this. So now I have x log of 2 plus x times the log of 3 equals the log of 3. Okay, so now what I'm going to do is I'm going to factor out the x, because both terms contain an x. So I can just factor out x and put that out front. And now I have the log of 2 plus the log of 3 equals the log of 3. Alright, so now what I'm going to do is, one of the great properties of logs, again, is if I have the log of same base, log of 2 plus the log of 3, I can actually multiply these together and write them as a single log. So basically, same base, when you have addition, it becomes 2 times 3, which is 6. So the x times the log of 6 equals the log of 3. And my last step here is to divide the log of 6 off. I'm just going to go over here. It's running out of room. So x equals the log of 3 divided by the log of 6. And we've just shown that x equals what it's supposed to. Alright, so lots of properties of logs in that one. Good practice problem.